Okay, so this is our next question from Cat23, the first slot. You can just pause the video and try it out and resume the video for the solution. So n be the least positive integer such that 168 is a factor of 1134 raised to n. If m is the least positive integer such that 1134 raised to n is a factor of 168 raised to m, then m plus n equals. Alright. So we are concerned with two numbers here, 168 and 1134. Let's start by prime factorizing these two numbers. 168 is basically 4 4s are 16 and 4 2s are 8, and 42 is precisely 2 into 3 into 7. So 2 into 3 would become 8 or 2 cube. 3 will be 3 raised to 1 and 7 will be 7 raised to 1. Okay, now 1134 may look slightly difficult to factorize, but if you observe carefully, the last digit is 4, so the number should be divisible by 2, and sum of the digits is 9, so the number is also multiple of 9. So if the number is multiple of 9 and 2, it is obviously a multiple of 18. So we can start by dividing this with 18. 18 6 are 108, and then 54 18 3s are. So 18 can be factorized as 2 into 9, and 63 is what? 9 into 7. So 9 square is 81, 2 raised to 1 into 81 is 3 raised to 4, and 7 is 7 raised to 1. Okay, so this is the prime factorized form of 1134, 2 raised to 1, 3 raised to 4, and 7 raised to 1. And above here, we have the prime factorized form of 168. Okay, now if you observe this question carefully, guys, the question tells us that 168 is a factor of 1134 raised to n. Now, 1134 raised to n will actually be, using the properties of indices, 2 raised to 1 into 3 raised to 4 into 7 raised to 1, the whole raised to n. This would become 2 raised to n, 3 raised to 4n into 7 raised to n. Now the question says this number has a factor 168, and 168 is 2 raised to 3 into 3 raised to 1 into 7 raised to 1. Now guys, come to think of it naturally, if the denominator is a factor of the numerator, it is basically completely dividing your numerator, right? So the powers of all the prime numbers in the numerator, they have to be equal to or greater than those in the denominators, right? So the power of 7 in the denominator is 1, and in the numerator it is n. So from here, n should be at least greater than or equal to 1. Similarly, the power of 3 here in the numerator is 4n, and the denominator here is 3 raised to 1. So 4n should also be greater than or equal to 1. And similarly, if you compare the powers of 2, the prime factor 2 in both the cases, the numerator and denominator, in the numerator the power of 2 is n, in the denominator it is 3. So n has to be greater than or equal to 3. So the least value of n which will fulfill all these three conditions will be n is equal to 3. So from here, we get the value of n as simply equal to 3. I'll write it here. And therefore, we can now write the new form of 1134 raised to n. 1134 raised to n will be equal to 2 raised to 3 into 3 raised to 4, 3s are 12, into 7 raised to 3. This is 1134 raised to n. So in the next part, we know that this number 1134 raised to n, this is a factor of 168 raised to m. So from here, we can write the value of 168 raised to m using the properties of indices. 168 raised to m will be 2 raised to 3m into 3 raised to m into 7 raised to m. As per the question, 1134 raised to n divides this number. Again, by the same logic that we have discussed previously, guys, all the powers of the prime factors in the numerators should be greater than that of the denominators. So 3m should be at least equal to 3. From here, m should be equal to 3. And from here, m should be equal to or greater than 12. And from here, the minimum value of n that will satisfy all the conditions will be m is equal to 12. So once again, I'll write it here. And now, as required in the question, we can easily figure out the value of m plus n. M is 12 and n is 3. M plus n, your answer will be 1, 5, 15. That is your C option. Okay, might look to be a lengthy question, but you can easily solve it using the laws of indices and some rules of divisibility and prime factorization. And that's how we do it. The answer is option C, that is 15.